How's it going, everyone? Welcome, Julio Gonzalez here. Today, let's going to now explore about is what is this Git remote, and especially what's going on behind the scenes when we try to fetch a remote branch or a remote state of the application, because at the end of the day, that's what Git is all about. And when it comes to push and so fetch, push, and pull. So that's what we're gonna look in today's video. So let's get into this. Brace yourself because we are going into that.
Terms, I'm going to use the term repo.
Let me actually take a break here for a moment. Yep. Stay with me. And we're back. So now, to make a quick recap of this particular course, which is pretty straightforward. So you have the introduction, the Git basic, the branching, merging, and rebasing, and then which is what we're gonna look in today's video, working with remote repositories. So how do we get here? Because since this is a course to understand now how Git data structure work, and anytime you do a merge, rebase, or cherry pick, you know what's going on behind the scene, and also when you create a commit and what happened when you do that. So this is something that was created by Linus Torvald, because he is so smart that we, the rest of mere mortals, can only keep up his pace by using his technology, by using this particular tools. Because that's the role of a TL at the end of the day, or any team lead. He can hold the entire system on his head, right? So when you need to do a bug fix or new features or remove some code, do some code cleaning, he knows where exactly need to look. So Git is follow this acyclic graph data structure that it means that one particular node can have two parents here. And to understand now what Git is, remember that at the end of the day, it's just a distributed version control system. So in other words, it allows you to now have a local copy of some projects, and based on that commit, you can recreate the entire project. So this is something that can be counterintuitive for a lot of people that are using this tool, which they think that it is storing only is diff, but at the end of the day, it's storing is the entire repo plus those changes, and now it creates now a commit. So in other words, it creates now a node on this data structure, this acyclic graph, where now it holds is, if this is the initial commit, it holds the parent, it holds is the tree, the author, and the committer. So the tree, the easiest way to think about this is now the folder structure, right? So this property, this tree property, has a value called SHA, or a commit, which is a SHA, a secure hash algorithm of 40 length characters that now points to where the file is located, as well as the content of the file, the dimension of the file in this binary large objects, where it's located, and also a SHA. Now when you now inspect that SHA using the git cat file -p, this particular command allows you to now inspect is the commit. So once you now inspect that commit that contain is a reference to the content of the file, so you can see now what's going on behind the scenes when Git create a commit. Or in other words, when you create a commit. So there's a couple concepts here that we need to be clear, like repo, which is a Git track project, the working area, or the working tree, where this is now the place that now Git actually keep track of your repo. And you also have different stages, whether it is the working, the unstaging, or the onstage, or the on track place, the stage, when you add those changes to this particular area, you can think of this like different boxes where you can put all of your changes here, similar to kindergarten. So when you have all of these different boxes, when you, for example, have now all of your toys, let's say Lego toys, here you have some other cubes with letters, and here you have now an empty cube, right? And then you now organize and put that from one place to another. So with this analogy, so we have these three particular areas: the on track, the stage, and the track. And anytime that you add some changes, you pass that from on track to stage. And when you commit that, you're telling to Git now behind the scenes that what you to create now is a node that we're going to now use that that contain is the commit, the author, the committer, the timestamp, as well as the folder structure. So that commit contains now a pointer to the file that points to the content of that file. So you can think of this as the way of how we can recreating is now our entire repo. Also, we look at some configurations based on the Git basics. So for example, what's going on when you initialize a project, which is now creating is the folder structure that allow Git to actually is keep track of that repo, okay? And also we inspect the folder structure, so what's going on behind the scenes, and anytime that you create a commit, now it adds that to the objects file, or to the object folders. And with that, all right, when we look also inspect at the git config, what are the things that you can do with git config? So for example, set up the initial branch, or also allow you to add some particular data that you might need to go with or use that. All right, under the section you find the key and the value of that, and you can also add or remove that and what is the order in which it does that. Then how can we now is starting to look at what's going on when we create a branch, which is just a pointer to that commit. So anytime that you create a branch, you say git checkout -b or git switch -c, it's creating now a branch. It's creating now under the ref folder a file that now store is the commit. In other words, it's storing is what was the last. So when you were at which commit you were when you create that branch, and from there it creates that. So we also look at how can we now is at least briefly, because once we look at this conflict resolution, we're gonna dive deep into this. So we look at the merging and rebasing. What is this all about? So merge is an attempt to combine two different branches into one single commit by looking at the best common ancestor, or aka the base merge, and from there replay all of this commit, and if you have any conflict you solve that, replay all of this commit, and then you merge that. So what it's gonna do is that from your current branch is going to now look at the common ancestor from the current branch you are, and the target branch is gonna look out for the common ancestor, all right, and then it's going to now replay all of those commit, and if you have any conflict you need to solve that, and on top of that you're going to create now this merge commit. So for example, if you have now two branches with different history, all right, well, it's going to prompt you is this message input. However, if you want to merge now a branch where the base merge, or the most common ancestor is the tip of the branch of another. Yeah, is the tip. What is it? It is the tip of the another branch. All right. And if you want to merge that, it's not going to create a commit. In fact, it's going to do a fast forward. Why is that? Because now the base merge or the most common ancestor is now has the same position. In other words, these two branch doesn't have different histories. And this is important because when you look at rebase, it's something that a lot of people actually hate because they don't understand what's going on behind the scenes. And what rebase allows you is to now alter the history of your entire gate. So how does it work? Well, by now, if you have now two branches, all right, that has, for example, if you have now two branches, and then you want to move now that branch to this position, all right. So this is the base merge or the most common ancestor, and then you want to move that, all right. So now it becomes something like this. The idea here is that with rebase, it now create a temporary, so it store the branch that you want to merge temporarily or rebase temporarily, and then it's going to reset the base merge commit or the base merge, reset that commit that points to now to the tip of the target branch, all right, and then is when you now going to replay all of those commit on the tip of that branch. So this is something that it can be quite confusing at the beginning, but the idea here is that once you get familiar with merge and rebase and all that kind of stuff and so on and so forth, you now can understand that when is the most common use case for merging and branching. So for merging is for saying, hey, you know what? Do that for public branch and do a rebase for private branch. Because if you change the history of the public branch, you're gonna break that for everybody, and then you have a problem. So be careful with that. Be careful with that. We also look at how can we work. What is the head and the ref lock? So head is just now is at the last commit that you are currently at. So head is just pointing to the last commit that you are. It can be in a branch or so on and so forth. And also, you have now ref lock that actually keep track of where the head has been. And if you have this lock, you can also is bring from the dead is all commits. And this is why we look at this particular example here, ref lock and cherry pick. So for example, let's say you create now some changes and then you add and remove, and then you, let's say you create that, right? Let's say you create now a new branch with these new changes, but then suddenly you delete that. Oops, you did that. So what you can do is by looking at ref lock, this head locks or where the head lock has been, okay? Now we can say, all right, let's get into look at what is the commit, okay, and then now replace on top of our and then replace that on top of our branch, right? If we want us to bring those changes to our branch. This is why cherry pick is so powerful, and you have your working directory must be clean in order to use now cherry pick. So that is quite interesting. All right, let's say you're working with something, and then you now suddenly, so you can use this or git stash as well. Something that we're gonna see that later. I don't know why they don't mention that. For example, git stash. I'm assuming that we're gonna see that later on. Assume the latest commit was already done. and so on and so forth. So in any case, yep, there we go. Here we are. So let's get into this. Let me make a quick pause here. All right, so let's take a look now at working with remote repositories. So remote git and fetch. Okay, so a remote is just a copy of the repo somebody else, right? So it can be is on your local, where you can now fetch those git history from one folders, from one path to another path, your local machine, or it can be fetched from another machine, right? So we went through that. So actually we didn't know that this is also capable, all right? That we can now add is not only a remote repo from, or in other words, another project in somebody else's computer or in our own computer, right? Which is great, which is great. We also look at what's going on when we did that, and also with fetch. So fetch, we can fetch all of the git state from our remote repository by executing git fetch. This won't update the current branches checkout, just where the origin has been set to. This is one of the reasons why you want to do is now a git merge from that. Because git fetch only fetch is the git state from a remote repository by executing git fetch, but this won't update the current branch checkout. Okay, so it fetch all of the state of the git, but it doesn't check out to the current branch, just where the origin has been set to. So now let's go to fetch git history from our origin to our folder remote git, which is something that we did. We just only fetch that, all right? But this didn't check out that. So we fetch the entire history here, all right? And if you have now a long git history, that's something that can take quite a amount of time. And if you want to be efficient, time efficient, you just only fetch is that one to actually give you is the last commit, which is something that you can do with git pull. So git pull fetching is always a good idea, but it keeps your local repo remotes up to date, but it doesn't alter your state. The thing is that a lot of the time you just want to change, you just want the change merge for you into your branch. This can be done with one convenient command. You want to merge this change. You want to merge for you into your branch. Let's talk about it. Git pull. Yeah, let's talk about it. Let's definitely talk about it. Let's definitely talk about it.
Repo. A repo simply means a project tracked by Git. It's a folder, or I use folder because I grew up with Windows. That's just how it works. It's a directory on some people. All right, so you can also use git pull. Fetching is always a good idea. Keeps everything up to date. I always try to fetch often, see when changes happen, and then pull in any changes I want. Git pull is just like a convenient form of what we just got done doing. Fetches the changes and then merges those changes into your branch. And so you can do git pull, the remote, and then the branch name. You can also.
So it's only fetching those changes. With git fetch, is only fetching is the state of the application, but with pull is fetching those changes and merging into your own branch. change.
So for convenience, just use git pull, and it will use the current one. Back in the day, like 15 years ago, or whenever I started using git, when you'd use git push, it'd push all of your branches up. It was fantastic. It would just send everything. So when you were just on your own branch and you get pushed and you had changes to the main line, you actually just got done updating the company's main repo with no testing or anything. Oh man, those were just the days. Absolutely a lot of fun. And so, let's add one line at the end of the README in hello git, and with the commit message, a remote change. But before you do that, I've noticed something, and I want to make sure we don't have any accidents. If you merged or cherry-picked changes into your trunk, you will have this extra commit. And I just want to make sure everything goes swimmingly from here on out. So if you've done this, has everyone done this, right? Okay, because it will diverge slightly from what's on the screen, because I didn't include that when I was printing everything out. So if you've done that, it's okay. I just want to make sure you know that it's there. And so if it's slightly diverging, there's no problems. All right, so let's add the one line at the end of hello git on your remote trunk. So I'll navigate over to hello git. I will echo in a remote change.
A remote change.
As the last line of README. At this point, it becomes important to make sure you're doing the same changes, because we're going to kind of get into some trouble here soon. So I'm going to go vim README, go all the way down to here, add this in, add it, commit it, a remote change. There we go. So hopefully everyone can do the same thing to hello git. I did not use status. Remember, again, it is good practice to use status. Since these are so trivial, I probably won't use status all the time, but typically I never git add without doing a git status. And for those that don't know, git add dot adds every file starting at my directory that git can find that has changes. So usually you do like git add path to a specific file, but so for convenience you can do git add dot as long as you have a good git ignore setup, and everything's really, really nice. All right, now we're gonna execute a git pull on the remote git. So I want you to open up remote git and just go git pull, right? Because we have trunk in remote, we have trunk in hello. Hello has been updated. We just want to pull in the change. It's going to error. I want you to tell me why it errors. So I'm gonna switch over to remote. I'm gonna git pull. The error is pretty simple. It's just because you have a branch named trunk doesn't mean that git's going to just magically assume that the trunk on another branch is the same one. You have to set tracking information. You have to tell git which remote are you linking this branch to, because you could technically have a bunch of remotes. Which remote should it choose? And so you have to have some sort of way to set the exact thing that you're tracking. And so the easiest thing for us to do is to take this line right here with git branch, execute it, and we have origin, right? We only have one remote. And it's literally saying git branch set upstream to origin slash trunk. And I'm going to do it for branch name trunk. And so now that I've done that, I can now pull in those changes. Because now it knows when I execute git pull, it now knows where to pull stuff in from.
Exactly.
And back in the old days, git pull would just pull all the things, right? I'm glad those days are gone. Man, did I mess up some serious repos back then. All right, so hopefully you can think about GitHub now, and you realize what GitHub is. It's just your repo on someone else's computer. That's all it really is. Like, we're doing the exact same things you'd be doing with GitHub, except for we're just doing it locally. And so again, hopefully the magic is now even less. Now, there's specific ways in which you can communicate to GitHub that we're obviously not doing here, but it's less magical. All right, so what about rebase? Well, typically whenever I pull changes in from my authority repo, I prefer to rebase the changes in. The reason why is that, again, I like a nice clean history. Any changes I'm making, I prefer my changes at the tip, because if I want to do testing again, I don't want my changes somewhere deeper in the history. I want it exactly at the end where I can edit those, I can squash those, I can change them. They're still my changes until I commit them to the public repo. And so that's how I like to live. I think rebase is the best. We'll go over sort of why it's the best. I know it's my opinion, but I believe it's the correct opinion. Also, it doesn't really matter whether you use merge or rebase. If you have a long-lived feature branch, life sucks. So there's just no way around that. Whether you're using rebase or merge, it's just going to be a pain. So there's not like a super special strategy to get around that. By the way, so the reason why I personally like
a long-lived branch with a bunch of merge commit is much more difficult to revert. If every change is a single commit, then ability to revert is very trivial, and that's what it is when you add small changes to this. Is because now you can easily replay each one of those individual commit is one of those individual state of your app, and then do that.
Like the rebasing approach is that every now and then I need to revert something, right? So if I am under really strict practice, of always moving my changes to the front with rebase. I'm always squashing them down to a singular commit. If that one day does happen to come by where you actually mess up production a little bit, a singular commit with no merge commits, with none of that, is very easy to revert. But if you have 6 commits with several merge commits in between, reverting is just more challenging, because now you're going to have to figure out how to pull out all that information and make sure that it is now
especially
updating. It's just a lot more. It's a huge bang. So this is why I choose this way. It's very intentional. I'm planning for failure as opposed to planning for success, which is why I use rebase. By the way, if you like rebase and you prefer to use it, you can actually just add it to a config. I actually don't have it set as a config. I always like to kind of manually, I don't know. But you can just simply do git config add global poll rebase true, and it will always do that. Don't do that now, because, well, we're going to do some merging and then some rebasing as well. So I just want you to know that that's a thing. For now, you can just do git pull -- rebase, and it will pull.
And we are back. All right. So git fetch is thus there. So git fetch download objects and ref from another repository. That's also why it's important to get yourself familiar with the documentation, wherever it be, bro. So git fetch, now put it in white, exactly. Git fetch download objects and ref. And if you remember what objects and ref is, the commits and the branches from another repo. So far so good. So you are fetching all of these objects and branches or ref. Good. However, limiting fetching to a specific number of commit to the tip of each remote branch history. The other is, hey, I want you to now git pull. Okay, if I say git pull, fetch from and integrate with another repository or a local branch. That's interesting. So with git fetch, it only fetches the data from the commits and your branches, okay? But it doesn't merge those in your local branch. Fetch from integrate, fetch from and integrate with another repo or a local branch. The description: incorporate changes from a remote repository that can be either in another machine or in our local machines, but in a different folder, okay, into the current branch. But incorporate changes from remote repository into the current branch. If the current branch is okay, oh my god, that's one of the things that when you do git pull, it actually fetch from every branch. But no. I wanted you to do that from here. If the current branch is behind the remote, then by default it would, exactly. If the current branch is behind the remote, so then the current branch will fast forward to the current branch to match the remote. If the current branch and the remote has diverged, this is when you're going to is or merge or rebase. Okay? So then by default, exactly, if the current branch and remote has diverged, has different stories, the user needs to specify how to reconcile different branches with rebase or no rebase on the corresponding configuration option in pull.rebase. More precisely, git pull runs git fetch with a given parameter, and then depending on the configuration option or the command line flags, will call either git rebase or git merge to reconcile diverging branch, different histories. Okay. So if your local changes are behind, exactly, if the current branch is behind the remote, when you run git pull, it will do a fast merge. In other words, it's going to it will fast forward the current branch to match the remote. Exactly. If the current branch and remote has diverged, okay, then it is up to the user to know what will be the strategy that we're going to use to reconcile that. Whether it's looking at the merge by going backwards into the at some point in the past where they have now the same base branch or the same base common ancestor, and they create a commit, or if you want us to now is get do a rebase, and I would prefer to. It makes a lot of sense. Oh crap! So when you git pull, it makes a lot of sense to use is now a git rebase, especially if you have different branches, because now you can say, hey, I want to now is update the pointer of this base branch that points to the tip of the remote branch, and then apply on top of that my new changes. That makes a lot of sense. Jesus. More precisely, git pull runs git fetch with the given parameter, and then depending on the configuration options or command line flags, we'll call either git rebase or git merge to reconcile a different branch. Interesting. Repository should be named on the repository. So this is a good example here, right? Let's say that this is now master on origin. The default values on repository and branches are read from remotes and merge. Configuration for the current branch as set by git branch.track. Assume the following history exists and the current branch is master. Okay, so we are now in the current branch master. Okay, origin master in your repo, and this is master on origin remote, right? So git pull will fetch is the history from the origin, all right, and replace the change from the remote master branch, since it's diverged from the local master. So it now say, hey, I need you to is reconciliate this. So it say we'll fetch and replace the change from remote master, since it diverged from the local master. It has E until the current commit C on the top of master, and record the result in a new commit along with the names of the two parents. So what it's gonna do is to say, hey, I'm going to create now a new commit. All right, this is if you want to do the merge strategy. Exactly. I'm gonna create now a new commit. All right, that will contain is now this. I will create a merge commit until the current C on top of master, and record the result in a new commit along with the name of the two parents commit, this one and this one, and log message from the user describing the change. But again, this is the merging strategy. Git merge for details including how conflicts are present and handled. In Git's 1.7 later, to cancel a conflict merge, use git reset merge. Warning: in older version of Git, running git pull will uncommitted changing is discouraged. While possible, it leaves you in a state that may be hard to back out in the case of a conflict. In any of the remote changes overlap with local uncommitted changes, the merge will be automatically cancelled and the word 3 untouched. It is generally best to get any local change in working order before pulling or stash them away with git stash. Okay, but this is interesting because this is the behavior by default is now merging them. But instead of actually merge, or instead of actually creating now a merge, which is make it very hard to go back and trace back at which commit actually you, so at which commit you can now replicate the entire project in a good way, in a good state. That makes a lot of sense. Holy moly, bro. Shit. Okay. So while possible, it leaves you in a state of that. That makes a lot of sense. So we know the difference between git fetch and git pull. All right. Okay. So to be more technically, so this is git fetch. So git fetch only fetch you is the state of the app. Okay. So git fetch only download is the git log history, but it doesn't merge those changes with your local branch. with your local branch. So for example, if we go to this example here, and then we say, hey, you know what? Into our local branch. So this is our problem. It's a problem. The solution. What you do? Solution. Okay. Let's going to create now this, and in this case, I need you to be to follow the instruction precisely because I don't want to do.
I just want to make sure you know that it's there. And so if it's slightly diverging, there's no problems. All right, so let's add the what. I will echo in a, what is it? A remote change as the last line of README. At this point, it becomes important to make sure you're doing the same changes because we're going to kind of get into some trouble here soon. So I'm going to go vim README, go all the way down to here.
Exactly. So let me go, instead of go to vim, I can actually get into vim to get myself familiar with. Maybe, who knows. Yep. So I have now is vim readme. Okay, I don't know even how to move around this. So I got is A, D, A, and a remote change. I don't know even how to add something here.
At this point, it becomes important to make sure you're doing the same changes because we're going to kind of get into some trouble here soon. So I'm going to go vim readme, go all the way down to here.
Exactly. I want to now insert something. Exactly, so I prefer to go with the readme. And then I want to say A, D, and A. Then you say a remote change. So a remote change. You save this.
Add this in. Add it. Commit it.
Exactly. So git status. Git what? Git remote. It create now a swap there. Remove in a recursive way. In this case, is this readme header file? Okay. Git status. If I say git diff of the readme, right? That's right, I got these new changes here, the diff git index at the readme here, we just only add one line here. That's what it is. There you got it. So git add everything. And you say git commit with a message. That'll be is now
a remote change.
A remote
there
change.
We go. So hopefully everyone can do the same thing to hello git. I did not use status. Remember, again, it is, those that don't know, git add dot adds, for convenience, you can do git.
Oh, because this is on hello git. Oh my god. Oh, what I did. God damn it. Git log. Alright. I want to now make trunks to point to that. I say, hey, git cherry big. Alright. 2 points to this. 3, 6, 7. Right. So git. How can I? Oh shit. What are you doing? The French stove, man? So how can I delete a commit? How can I delete the last commit in this branch? Okay, for local only commits, not push, use git reset head to undo the commit but keep the change stages, or git reset hard to discard both the commit and changes. If you already push after resetting local as above, force push with git push. To override remote history, risky if collaborators use the branch. But in my case, I want to go with this git reset hard, the head one. Git reset hard, the head to 1. Why is this? Because we can say, hey, I want to do is the ref log, so git ref log minus, or with only 3, you show me that, and what you're doing is like, hey, I want you to move this to that. Git reset hard head to 1. So now we are here. If you take a look at git log, we are now remove all of that, all of those changes, and if you go to git ref log, you can see the commit there. Interesting. So for some reason, if you remove that and then you say, hey, no, I didn't want to do that, well, you know what to do and how you can bring changes back from the dead. Okay, so now if we go back and say, hey, I want to move to hello git, which is a remote repo, okay, and then we say, hey, from this trunk, I want to now take a look at the nano readme, and then add some changes and say, hey, a remote change, right, something like that, and I want to save that. Then we did it. Say git status, git add, everything under the repo that has changed, and then I want to create now a commit that will say a remote change, right? Once you do that, and then you go back to the remote git, and then when you say git pull, all right,
Git add dot, as long as you have a good git ignore setup, and everything's really, really nice. All right, now we're gonna execute a git pull on the remote git.
So this will throw us is an error. You can say git pull. Oh, it didn't. It didn't, because we tell now to do that. Give me a second here. So we're back, and yep. And so once we look at this, once we actually did this, it does a fast forward.
Hello, I'm gonna git
because
pull.
we didn't
We
have,
assume that the trunk.
Because we now have set automatically that upstream to
on
be
another branch
tracked on.
is the same one. You have to set tracking information. You have to tell Git which remote are you linking this branch to, because you could technically have a bunch of remotes. Which remote should it choose? And so you have to have some sort of way to set the exact thing that you're tracking. And so the easiest thing for us to do is to take branch 2, because you can
Finder. For real. So you need to tell Git what is the remote branch you want to track in order to merge those changes with your local ones. And not only that,
You can technically have a bunch of
it
remotes.
does
Because now it knows when I execute git pull.
it does a fast forward, right? It does a fast forward because we don't have any diverge branch, diverge history. Mm-hmm. That makes a lot of sense.
Pull, it now knows where to pull stuff in from. And back in the old days, git pull would just pull all the things, right? I'm glad those days are gone. Man, did I mess up some serious repos back then. All right, so hopefully you can think about GitHub now, and you realize what GitHub is. It's just your repo on someone else's computer. That's all it really is. Like, we're doing the exact same things you'd be doing with GitHub, except for we're just doing it locally. And so again, hopefully the magic is now even less. Now, there's specific ways in which you can communicate to GitHub that we're obviously not doing here, but it's less magical. All right, so what about rebase? Well, typically whenever I pull changes in from my authority repo, I prefer to rebase the changes in. The reason why is that, again, I like a nice clean history. Any changes I'm making, I prefer my changes at the tip, because if I want to do testing again, I don't want my changes somewhere deep within the history. I want it exactly at the end where I can edit those, I can squash those, I can change them. They're still my changes until I commit them to the public repo. And so that's how I like to live. I think rebase is the best. We'll go over sort of why it's the best. I know it's my opinion, but I believe it's the correct opinion. Also, it doesn't really matter whether you use merge or rebase. If you have a long-lived feature branch, life sucks. So there's just no way around that. Whether you're using rebase or merge, it's just going to be a pain. So there's not like a super special strategy to get around that. By the way, so the reason why I personally like the rebasing approach is that every now and then I need to revert something, right? So if I am under really strict practice of always moving my changes to the front with rebase, I'm always squashing them down to a singular commit. If that one day does happen to come by where you actually messed up production a little bit, a singular commit with no merge commits, with none of that, is very easy to revert. But if you have 6 commits with several merge commits in between, reverting is just more challenging, because now you're going to have to figure out how to pull out all that information and make sure that it is now updating.
But this is something that
just a lot more.
mentioned.
It's a huge pain. So this is why I choose this way. It's very intentional. I'm planning for failure as opposed to planning for success, which is why I use rebase. By the way, if you like rebase and you prefer to use it, you can actually just add it to a config. I actually don't have it set as a config. I always like to kind of.
There's a configuration for it. So there's 2 strategies for rebase in changes. Add rebase flag to pull, git pull rebase, edit your config to make this behavior the default behavior. Good thing we know about how to config works.
Manually, I don't know. But you can just simply do git config, add global pull rebase true, and it will always do that. Don't do that now.
But the practice
well,
here,
we're going to do some merging and then some rebasing as well. So I just want you to know that that's the thing. For now, you can just do git pull -- rebase, and it will pull it and do a rebase as opposed to a merge. Always moving my changes to the. Really like the rebasing approach is that every now and then I need to revert something, right? So if.
So the revert or the rebase approach on pulling. So any time you want to revert something, which is what happened to me exactly right now, you want to, or by following that particular practice. So I'm under really strict practice. So anytime you want to revert something, I'm following is a specific or a particularly or a strict practice, a strict practice. Okay, I'm following a strict practice. So always moving my change to the front. I'm following a strict practice. So always moving my change to the top.
I am under really strict practice of always moving my changes to the front with rebase.
Exactly. Always move my changes to the top with rebase, and I'm always squashing them down to a singular commit. Then always squashing down to a singular commit. And I think this particular practice is something that is
I'm always squashing them down to a singular commit.
useful,
If that one day does happen to come by where you actually
So if that day when you actually come by and mess up, which is going to happen because I'm planning for failure, not for success. If that one day when you actually come by and you mess up production, okay,
messed up production a little bit, a singular commit with
when you mess up production a little bit, a singular commit or a singular commit with no merge commit, with none of that, is very easy to revert. So a singular commit with no merge commit is simple to revert.
No merge commits with none of that is very easy to revert. But if you have 6 commits with several merge commits in between, reverting is just more challenging, because now you're going to have to figure out how to pull out all that information and make sure that it is now updating, just a lot more. It's a huge pain. So this is why I choose this way. It's very intentional. I'm planning for failure as opposed to planning for success, which is why I use rebase. By the way, if you like rebase and you prefer to use it, you can actually just add it to a config. I actually don't have it set as a config. I always like to kind of manually, I don't know. But you can just simply do git config, add global poll rebase true, and it will always do that. Don't do that now, because, well, we're going to do some merging and then some rebasing as well. So I just want you to know that that's a thing. For now, you can just do git pull -- rebase, and it will pull it and do a rebase as opposed to a merge.
Okay.
Yeah, look at that. I even warned myself because I knew I'd goof it up. It's just so easy to do that. So what's the opposite of pull? Well, push, right? Awesome. So if you wish to take your changes and move them to a remote repo. So what's the
Start to git pull, git push, so git push. Or in this case, this one. And git push. Okay.
The opposite of pull? Well, push, right? Awesome. So if you wish to take your changes and move them to a remote repo, you can do this with git push. If you're not tracking, git push won't work, just like git pull wouldn't work, so you have to be able to be tracking a branch on a remote. Again, if you properly name it as origin, Git has some magic around it where you check it out, it'll do some auto tracking for you, which is fantastic. So let's make some changes to bar and push it to hello git. So I'm going to go here in remote git, and I'm going to go git checkout bar. Now notice when I git checkout, look what it does. It automatically does the tracking for me. Awesome. So now I can just git push. And notice that I didn't have to create a new branch. I already had this branch in my remote directory. If you have several remotes, it can cause some problems, and all of a sudden checking out can be a little bit more of a pain depending on how you name things. That's why, the whole git checkout me bar I thought was funny, but it also can be a pain. Anyways, so we've now switched to bar. We'll do a little quick change. Let me just make sure that this is how we're going to do this. Let's see. Create a single commit changes from remote. There we go. And we're going to add it to the end of README. So everyone do that. Add one line to the end of README in bar.
So I'm going
to go vim, README, go down here, changes from remote, git status. Oh yeah, there's only one file change. Git add, git commit, changes from remote. There we go. So now I can take this and I can push it to my remote. So I can go git push. And look at that. We've just updated bar in hello git. If I switch over to hello git and go git log bar one line, you will see this right here. It's been updated for us. Because I pushed and it changed it on the remote. So this should be pretty familiar to you because it's like you already do this with GitHub a bunch, so none of this should be a surprise. Probably the only real surprising part is the fact that it's just 2 folders on your computer, right? Again, folders, directories, I know, Windows. Played Doom, loved Doom. Doom was a great game. So we pushed all the changes, we've logged it out, we can see all the changes, changed from remote. So that's pretty awesome, right? Now, you may be asking your question this: why was bar moved forward for us? We fetched the results. It didn't move our branches forward, but why wouldn't we push to do it? Well, we're not checked out, right? That branch isn't checked out. We're not using that branch in any sort of capacity. And we're doing a push, which is analogous to doing like a fetch and a merge. We're just doing it for them. And so that's what's happening on the other side. It's fetching, it's merging, it's updating its reference for bar. And there we go. It's like the opposite of pull. I'm going to every now and then say the word upstream instead of origin. Upstream, it is just by accident. Old habits kind of die hard. When I say upstream, I mean hello get. So when I say origin, I mean hello get. Because remember, we have a dependency of remote get on hello get, but hello get doesn't have its remote set up to a remote, right? So it's a one-way relationship right now. So we're just going to pretend hello get is GitHub for this case.
Okay. Stashing, exactly.
We are at this point where you have a change you've made locally, and now you have a change you need to pull in from remote. What do? Typically, most people say stash it. You can technically commit and rebase, and then you have your commit on top, but you pulled in the changes that you need. And so you kind of you do have options here, but there is a third option, which we'll talk about later, which is work trees, which is my favorite way to do this. So, but for now, we're gonna actually start talking about stash. So for those that don't know anything about stash takes every tracked change by Git inside the index and the working tree and stores them kind of into a special area, the work in progress area, the stash area. And you can think of stash like a stack of temporary changes. This is from the man page using git stash when you record the current state of the working directory in the index but want to go back to a clean working directory. The command saves your local modifications away and reverts the working directory to match head commit. All right, so pretty straightforward. Stash is a stack. I want to make sure I say that multiple times. It's just a stack of changes. All right, so operation, you can push to your stack by your stash by executing git stash. You can even give a friendly message with -m. So this right here would stash, but with a message. Stashes can be listed out with git list or git stash list and git show with an index as well. Show will just show the changes or the diff, whereas list will list out the amount of stashes you have. You can pop the latest stash with git stash pop. You can pop at an index with dash index. So if you want the third stash in, you can just dash index 3. Or I think it might be 0 based. I forget if it's 0 or 1 based. I assume everything's 0 based unless we're using Lua, so we'll just say -2 for the third option. All right, man git stash is your friend. If you forget how it works, again, use the friendly manual. Love the friendly manual. Read the friendly manual. That's what RTFM stands for, by the way. So if you ever see it on the internet, just remember it, the friendly manual. All right, so problem. We're gonna use trunk, and I want you to create an upstream change. Remember, this is gonna be in hello git. Just create a file called upstream and put upstream change into it. Then in remote, I want you to do a downstream change in the README. Okay? So remember, these are two different files, and I want you to do it like this. So I will literally copy this. I'm gonna go to hello git. Just execute that, git add this, git commit, upstream. Then I'm going to do this one right here, so I just don't mess it up. Look at that. All right, there we go. So now remote has a change. Oh, dang it, git check out trunk. There we go. Look at that. All right, there we go. Get this thing, and then add this thing, and then commit this thing. There we go. Okay. So make sure you do it to trunk, as I stated explicitly in the instructions, and would never accidentally deviate from said things. All right, so now, I actually did deviate. I said don't commit, by the way, the second one. Don't commit the changes. Did anyone commit the changes in remote git? You committed it? Do git reset --soft head tilde 1. I'll do it too. Git reset soft head tilde 1. There we go. Now I have that lovely little change right here, and trunk is now pointing one step back. Beautiful. Okay, so I have my remote git set up, but now we got this call, production's down. There is a change you need to make, or there's a change you need to pull in from our upstream. So we're going to attempt to pull it in with an active change. So let's start there. So do a git pull with the right here, git pull. Wait a second, did I miss one thing? That it should say, hey, you don't do that. I think it's probably because I have rebase automatically on. So I think I accidentally had my little change in where I had rebase true. So I was causing a bit of you cannot pull with rebase. So oopsie daisies, right? And so since I have an active change, it's not letting me do those changes. So whenever you try to pull and you have active changes, it's gonna tell you can't do this. So we need to be able to stash. So we'll just go like this. We'll do another one of those echo upstream change into here, git add this, git commit, upstream change. There we go. We have the upstream change in hello. Now we go to the remote, and we can go echo downstream change into the README. So now we have something in the README, and we have a change we need to get from hello. So what are we going to do now? We are going to use stash, right? So this is what you do at this point. You'd want to stash any of your changes to prevent any errors from happening, and then you're going to want to be able to get the changes, and then you're going to want to be able to unstash, right? So this is typically what you're going to want to do. So right now, before we do anything, let's stash our changes. So you can experiment by going get stash, and then go get status. Your changes are gone, right? Don't pull yet, don't pull. You can view your stash list. This is a good kind of activity to get into, viewing your stash list, because it's really nice to know that you can even do that. So again, get stash list. So if you ever get into this, you will know. So we have this work in progress that we've stored right here at this point in time. You can see, okay, I was at this commit. Not very informative though, right? When you look at this, you don't really know what your stash changes are or anything. So we can go get stash show. A little bit nicer to see, oh, okay, this is the one where I made a change to README. So a little bit nicer. Let's pop our stashes this time. And when we pop it, I want to see that it's now made that change. Get stash pop. There we go. Our change is back. It's right here. All right. Now let's stash our changes again, but this time let's use a custom message. So go get stash with a message. README changes. There we go. We did a stash again, but this time with a custom message. So now do get stash list. Now look at that. Isn't that a lot nicer to do? When you have a nice message, because the reality is sometimes you will have a couple stashes and you're not going to remember what's in these stashes. And so just having a nice little friendly message to yourself it'll just save a lot of headaches rather than trying to go through all the diffs and looking at each different one and then realizing, oh gosh, like this, there's the one I'm looking for. So now let's create another change and we'll stash that so we have 2 in the list. All right. So let's go another one. I'll just go vim readme and I don't know, just add another line. There we go. Dvorak, by the way. And then I'll go get stash another change. So now when I go get stash list, I'll actually see 2 changes. I have another change on top, and the README changes on bottom. So the README changes is the first set of changes we did. Another change is the second set of changes we did. But notice it's on top. It's the first one. So let's pull in our upstream changes now. So I'm going to go get pull. There we go. I have this beautiful upstream change. Now, let's get our original change back, the first stash we did. Does anyone remember how you're going to get the first stash out? Not the second, not the one we just added, but the first one. Past the index. There you go. So what you should be doing is going get stash. Well, first you can go get stash list. Make sure. Okay, I need to pull out the first one right here. Okay, I go get stash pop index 1, and now we have that proper change. We don't have the Dvorak one. Get stash pop. Right. We have the downstream change. So working with stash, pretty easy to use. Now we have this beautiful change on top. Awesome. And if we want to, we can even commit it if we want to, but stage is not changed. There we go. And it looks like even in here, I commit it, so we will commit it with the exact same beautiful message that I have right here. Oopsies, that's copying from terminal. Get add. Greatest change. Fantastic. There we go. So commit that into your code. That means your README should approximately look like that. I have a little space in here. It's not. There's no space in my example one. It's because my first commit contained that. It's that one right there. See, look at that. I added a space, but in all my examples, I didn't have the space. Very painful for me to see this. I can't believe I did that. By the way, if you don't know, I don't cover it in this course, but -s will search like your commit message, or it'll search the commit change, so you can look for changes that way. Very, very fantastic. That's how I knew where to find it. That's how I found it right away. Pretty neat stuff, just in case you're wondering. All right, so work trees. We're going to talk about this in a... Very fantastic.
So git log search from message commit.
So I knew where to find it. That's how I found it right away. Pretty neat stuff, just in case you're wondering. All right, so work trees. We're going to talk about this in a little bit, I believe. I'm not sure. Yeah, we're not talking about it right now, but we're going to talk about it in a little bit. The thing that makes work trees so cool is that a work tree is another copy of your repo without all the weight of a repo. So if it takes you 5 minutes to download to clone out a repo, you can build a work tree effectively just as fast as you can build a branch. They're very, very lightweight, and they're fantastic. So you can see why that could be a very nice alternative to Stash. All right, so we're going to do more rebasing. This will be the longest section here, and it's going to have all the conflicts and everything, and we're going to go over it. It's going to take a little bit. So anyways, rebasing, you can do things like this, where we start off here, right? E is
And then
branching
you wanna
off of
move
A.
is, for example,
This
is
picture makes it look like it's branching off of B. I'm not sure which one I chose to have it actually branch off of. It doesn't really matter. It branches off in the days of history way back then. And if you do a rebase, you can make it so that it goes all the way to the front,
Like
right?
this.
We all remember this.
You
What are the
put
steps
it
that
all
happen?
over the
Step
top and
one,
the front.
we check out the branch we're rebasing on. Step two, we play our commits one at a
Ultimate
time
one
at
at
the
a
tip of
time
the
at the
branch
tip
we are
of the
rebasing on.
branch
Three,
we're
we
rebasing on.
update the branch we were on with the new position and the new commit. That's why it alters histories, because remember, it's actually creating a new set of commits. Because remember, a commit it also contains time. So that's why you get new commits when you rebase. All right, everyone's good? Everyone's good on that one? Awesome. All right. So first, let's do a little bit of interactive rebasing and squashing. So this part is where you'll do this pretty much on your own branches, never on the public one. Interactive rebasing and squashing allows you to take, say, this branch right here and turn it into this.
Into
where it's
one
a singular
commit.
commit as opposed to 3 commits. So that means while you're working, you can make all the commits you want, every single checkpoint, and then when you're done, you can take all those commits and turn it into one commit yourself. Now, a lot of people do it where they have the remote, like say GitHub, will do an automatic squash merge for you. They'll first take all of your commits, squash it into one, and then merge it onto GitHub. That's a pretty common strategy that I've seen. I know we do it with Stash and stuff like that at Netflix, so I think most people probably have some very similar experience. When you do interactive rebasing, it also allows you to edit the message. So that way, like what I typically do is I'll do each one of my commits and I'll start with squash me. So I can just look in the history and go, okay, where did I start? Okay, I started right here, rebase from right there. And then it's very easy, then I interactive, and then I can just erase all the messages and give it a nice proper message, as opposed to a bunch of squash me's, right? And so we're gonna create some situations where we can interactively squash our commits and get some good messaging. There's a lot of ground to cover here. We're gonna go over conflicts, because conflicts are a very important part of this. If for whatever reason, I've done steps out of order and we're unable to create the conflict as easily, we might have to add some extra commits, because that's part of the fun, is that we didn't do it right the first try. So be very careful where we make changes, because from here on out, we're gonna be trying to make conflicts and we all want to be on the same page. So the first, by the way, conflicts are the most dreaded topic. I hate them. I don't know why. I have an unreasonable amount of anxiety every time I pull a there's gonna be a conflict, and even though I know there's not, I still just feel like I'm gonna have a freak out. I don't know why it is. It just is that experience. Yeah, I hate them, you hate them, but it's good to know how to resolve them. Please, by the way, don't use VS Code, don't use Fugitive with Git or with Vim, don't use any of those for this. Let's just manually edit the diffs. You want to see why they're doing this. It's gonna be very important, especially with your knowledge of rebase, why conflicts can be goofy with rebase versus merge. We're gonna go through it all, but if you're not using the hand edit, and you're just using a program, you may miss some of these subtle changes.
Yep, that's what it is. This will be quite large, bro.
All right, so to create a conflict, the easiest way to do that is you just have...
Okay, so that'll be all for this video. Take care. Bye-bye.